Okay, so we are having the next topic, that is law of conservation of angular momentum. What does it mean? It means that we are having the topic. What does it mean? It means that in the absence of torque, when the torque is zero, in the absence of torque, the total angular momentum is basically conserved. What does it mean? It means that when the torque is equal to the zero, so the angular momentum is conserved. How? Let's see. So as you guys all know, we are having the formula that is R into F. Okay, after that, as you guys all know, that R and F is equal to what? F is equal to, as you guys all know, we have discussed in the in that that is change in momentum into the change in time. So we are having the change, and so we, as F, we can write here change in momentum into the change in time. Okay, so as you guys all know, this is equal to what? This is equal to the first, so we can write here that this one L is equal to, which L is what? L is basically the angular momentum, so we can write it L, angular momentum, is equal to the R into P. As you guys all know the formula of the angular momentum. So we can write here that we are having the formula that is torque is equal to the change in you can say that the angular momentum upon time. So we can write here that angular momentum is equal to the time. So we are having this torque as 0, as you guys all know. So we can write here that change in momentum is equal to time. Okay, so here you can see that this will multiply by 0, so we are having the 0. So we can here write here change in this one as the 0, change in momentum in the is equal to the 0. So as you guys, we are having change one sign, so we can write here that the angular momentum final minus angular momentum initial is equal to the 0. Okay, so we can write here this is having 0, so we can write here that the angular momentum of the final and the angular momentum of the initial is equal to the is equal. So this is when they will be getting equal, so the you can say that the with this is what this is will be equal when the torque is equal to 0, and through this we are there is a equation which is showing that the angular momentum is conserved. Okay, so we are having the linear momentum formula, that is P is equal to mv. So we can write here that P, if we are having angular momentum, so angular momentum, and through m we were having the moment of inertia and the angular velocity. As you guys all know, this was the formula that we have derived through the, you can say that the this one in the angular momentum. So this was the linear momentum and this is the angular momentum formula. Okay, so we can write here that we are having this one is the next form, this is the another formula of the angular momentum. Okay, after that we can write here we were having this one as a is equal to the angular momentum final and is equal to the angular momentum initial. Okay, so as you guys all know, we were having this one as this is the final is equal to this is the initial. So this was what? This was the, this is what? This is the angular momentum. So we can L is equal to the, this one is the, you can see the moment of inertia into the angular velocity. So this was equal to this, so we can write here, and this is the final one and this is the initial one. So when they will be both equal, so the angular momentum will be conserved. Okay, and there you can see the ratio will be same. Okay, so we are having this one, so we can write here that I is equal to what? I dot, this is what the angular momentum and is equal to this one, what the equation. Okay, so here we are having this one as a, we can write here the meter into the second meter square, we were the as a moment of inertia, meter r square dot, we are having this one as this one, and here we can also write there here this as a initial. Okay, so this is the final equation. Okay, so it means that we are having the formula that is law of conservation of angular momentum is having this one formula, that when they will be equal, so the angular momentum will be conserved when this the torque will be equal to 0. Okay, after that we are having the next topic we are having, that is the relation between torque and angular momentum. Angular momentum. Okay, so as you guys all know, we are having the formula of the torque, that is into alpha. Okay, so as you guys all know, alpha is equal to the change in angular velocity upon time. So we can write here that change in angular velocity upon time. Okay, so after that, as you guys all know, we are having this a change one sign, so we can write here that the final minus initial upon time. Okay, after that, as you guys all know, we are having this one, torque is equal to initial, so we can write here that this is multiplying with this and this is multiplying with this. Okay, so here you can see that we can write here that, as you guys all know, that we were having the formula of the angular momentum was moment of inertia into the angular velocity. Okay, so we can write here that this one, L is equal to what, this, so we can write here L final minus L initial. Okay, as you guys all know, L is equal to I into V, so we can write it I into V is equal to the L and F. Okay, so we have this. So after that, as you guys, after that, this is the time is equal to this. So this is what, this is the change, so we can write here this is the change in the angular momentum upon time. So we can write here the formula of the angular momentum, the rate of change of angular momentum is called torque. So this is the next another formula of the torque. Angular momentum is called torque. So this was the relationship between the angular momentum and the torque. So this is the another formula of the torque. So this was the relation between the torque and angular momentum and the law of conservation of angular momentum. In the next video, we'll discuss about the equilibrium.